You're not playing no game?
Alrighty then. Alright, so.
You're not going to answer my question?
Nope, I'm not. Alright, page 33 right here. We have Cavalieris principle.
You answer my question.
I'm not going to answer your question.
We need to.
Listen, Negative Nancy. Alright, so. Right here, Cavalieris principle, composite volume. Okay. Now, oblique prism. Now, what? Thank you. All right. So I have here.
What you got?
I've been saving this for this right here.
And why is that?
So now here is an example of an oblique prism.
Okay, oblique prism.
If you notice,
I notice.
I have a stack, right?
Stack of money.
So together, all this makes a
rack.
A rectangular prism, right? Mm-hmm. So it has width, it has depth, it has volume, right?
Yeah.
So to figure this one out, I would actually do the length times the width times the height to find the volume, right? Mm-hmm. Yes?
Yeah.
Mm-hmm. Okay, good. Now, tell me, will the volume change if, watch this. I'm going to take this, I'm going to slide this over like this. Mm-hmm. Ah, come on, work better, work better, work better. All right, there. Now, is this now going to have a different volume?
Mm-hmm. No.
No, of course not.
It's not going to have a different volume, is it?
No.
No, it's just that same stack that I had, but I have now slid it, so it's now going to look kind of like this, right?
Yeah.
It's looking just like that. So it is an oblique prism. So it's that same rectangular prism that I just slid over. So now when it stacks, it has the same volume, but it is in a different shape. That's what the Cavalieris prism is, or Cavalieris principle is. So you take the same thing and just slide it over. Okay? Same thing works with a pile of money. And I have a pile of quarters here. I should have taken them out earlier, but anyway. So I have a pile of quarters for this demonstration. Malik, quit trying to steal my quarters. What? All right, so here is it's basically a cylinder of quarters, right? So it's kind of like this one right here. So I have a cylinder. So when I stack them on top of each other, it gives it a height. So it's kind of like the area of the circle, which we have here, times the height, which is here. So that would be the cylinder. But if I take that same cylinder and I slide it over like that, I'm now going to have the same volume, but the shape is slightly turned. It just slid over like this. So that's where we get that from. So we have the same on top as we do on bottom. So same shape, same size on top and bottom. It's just now slid over. That's what the Cavalieris principle is. So this piece right here is going to be the same as this piece right here. This piece right here is going to be the same as what I have down here on the bottom. So it would give me the same volume as the regular shape. It just slid over a little bit. If two solids have the same height and the same cross section, remember a cross section is if I slice it, kind of like this right here. I could slice this one right here. Watch, watch, watch. I'm going to slice this cylinder in half. Ah! Now I get two smaller cylinders, right? Look, look. Ah, back together. See that magic? Bam! Woo! Look at that. Okay.
No, stop.
Okay. Now, from your notes that we did the other day, what is the volume of an oblique cylinder? Here's the cylinder here. Okay? What is the volume of this supposed to be? Volume is, come on, we did this the other day. What's the volume? What's the formula?
Half times
Base
base
times
times
height.
At the base time.
Times the height.
Pi
Times radius squared.
R
times
squared.
height.
Pi r squared.
times h. This should be on what page? Like 31?
33.
31 is where we actually did that?
No,
I think so. I don't know.
me neither.
Is page 31 where it has the formulas?
Yes.
Okay. So you're going to need the formulas for this. So now we have this. Right here, the radius is given to me. So volume should be pi r, which is 12, squared times height, which is 45. Plug that into my handy dandy calculator.
Handyman.
So, pi pi parentheses 12 close square.
You are too. Jim.
Please stop. Please stop. Times 45, right? There you go. We should come up with about.
About.
Remember, symbol for about right there. It's going to be 20357.5. What are my units?
Inches squared.
Inches what?
Cube. Cube.
Why is it cubed?
This is volume.
And volume is always cubed, right? There we go. All right, so now this one right here, example 2, what is the volume of this oblique rectangular prism? So rectangular prism is the volume I'm looking for.
Is it?
The volume is supposed to be what? Length times
Height.
there we go. So my volume is going to be equal what? Don't say like tell me the numbers.
9 centimeters.
9 times 4
4. Times 6.
times 6.
Wait, it's 9 times 4 times 6.
9 times 4 times the height going straight up and down is 6. Was it like 218? 216. So my volume is 216. What are my units? There we go, centimeters cubed.
Wow. Amazing.
That is fascinating.
¿Está muy fácil? Sí. All right. Let's take a look at the next part. It says composite volume. Now, composite is the same as saying compound. When we said compound, what would that mean?
How much is it? Compound.
We did compound area
Don't you separate them?
was what?
Don't you separate them?
We separate them, but for this one, is this going to be an addition or subtraction?
Addition.
It's addition, right? So I have a rectangular prism with a cylinder attached. Because I know everyone in here is paying attention right now.
I'm looking down. I'm listening to you. Unlike you guys.
All right, trying to throw shade. Anyway, so we have two different shapes right here. So we have a rectangular prism and a cylinder. Let's take a look. My rectangular prism, it's going to be 14 going this way, 6 going this way, and we need the length of this one, right? What do you think that's going to be? 12. It's going to be 12 going back this way, right? Volume would be 12 times 14 times 6.
What is it?
Y'all got calculators.
1,008.
What is it?
1,008.
1008. And that's going to be,
P, Q.
there we go. So that's that piece right there. That's just the rectangular prism. But now we have a cylinder attached to that, right?
Yeah.
That would be the volume, which would be pi r squared h, kind of like what we had up here. So it's going to be pi. What's the radius of this one? 4. Right? Radius is 4. It's this value right here. And the height, what's the height of the cylinder? Look at right here.
14.
It's 4. It's this one right here. From- Okay. So there we go. So everyone should be calculating what we got here. So everyone should be calculating, not staring at me awkwardly, remember? That calculator is your friend.
It's 201.
What is it? You said 201?
Yeah. Point.
0.1.
.1? And that's again going to be in? There we go. So, I found the volume of both pieces. So what do I do now? Add them together. So go ahead, add those together. My total will be 1, 2,
Oh, 9.
9.1 feet cubed.
Oh my God. We did it. Hooray.
All right, let's take a look at this last one right here. Now, for this one right here, it says find the volume of a roll of paper towels. You know about a roll of paper towels?
Yeah.
What's in the center?
A cylinder. Circle.
A cylinder, right? Is it full?
No.
It's empty, right?
Yeah. It's
So in that case, I would actually have to try and figure out a couple things. I need to figure out the whole thing, and then wouldn't I take away the inside? I would subtract the inside. So let's take a look. From all the way across, I'm going to do it down here so you guys see this. All the way across, if it's from here to here, what is it all the way across?
4.
This side is how much?
2.
This side over here is?
2.
This is?
2.
Just right in the middle is 2, right? So all together, all the way across is going to be? There we go. So it's going to be 6 all the way across, right?
Yeah.
So what's going to be the radius of the big cylinder?
3.
It is 3. Very good. So my volume would be pi 3 squared. And the height? 11. I know y'all people are calculating.
Yes, sir.
What is it?
311.0.
311.0.
Yeah.
Okay, so now let's find the volume of the small cylinder. What's the radius of the small cylinder?
1.
It's going to be 1. Very good. So the volume would be pi 1 squared times the height, which is 11.
34.6.
So 4.6.
Yeah.
Now, to figure out the total, what would I do? I would subtract. Because it's the big one minus the little one, right? So my total would be big one minus the little one. So I would take this, subtract that. So my total,
276.4.
276.4. What are my units?
Inches cubed.
Inches cubed. So I'm going to go back and put inches cubed for all these. Does that make sense?
Yeah.
Yeah.
Okay, so let's take a look real quick at the practice for today. So, number one, what do we got? We got a rectangular prism and another rectangular prism, right? What would I do? Add or subtract? Add. What about this thing? That one's just regular cylinder, right? Number 4, what do you think 4 would be? It would be an add, wouldn't it? Because I have a rectangular prism plus a triangular prism, right? We did a triangular prism the other day in the notes. Okay, on 3, it's the same as what I did in the notes, right? I just have a bigger side right here. So just so you know, the diameter is 30 here. The diameter is 30 here. So this is 30 all the way across. Okay? This one right here, I have my prism, subtract my cylinder, right? Cylinder and cylinder. Okay, is all this making sense? Pretty straightforward, right? All right, don't forget, like, share, and subscribe.
Comment below.
Leave a comment below.
Don't leave a comment below.
Just like the